Problem Introduction. Hey everyone, and welcome back to the channel. Today, we're tackling LeetCode Problem 30, Substring with Concatenation of All Words. This is a medium-level problem, and it's a fantastic example of how dynamic programming concepts can be applied in a clever way. The problem statement asks us to find all starting indices in a given string where a concatenation of a list of words can be found. Think of it like this. You have a large text and you have a set of words. We need to find all places where those words appear consecutively in the order they're given within the larger text. We're given a string called text and a list of words called words. Each word in words is the same length. Our job is to return a list of starting indices where this concatenation of words appears. It's a bit more nuanced than it sounds, but don't worry, we'll break it down step by step. We'll explore different approaches to solving this, focusing on the most efficient solution. Let's dive in. Understanding with examples. Let's understand this with a couple of examples. Suppose our text is bar foo foo Bart foo bar man, and our words list is foo bar. Notice how foo bar appears twice in our text. Our algorithm should identify the starting indices of both 0 and 9. Let's consider another example. Text is word good 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 best word, and words is word good best word. Here, the concatenation word good 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 best word appears only once, starting at index 0. The key here is that the words must appear consecutively and in the exact order specified in the words list. We'll work through these examples step by step as we implement the optimal solution to further solidify our understanding. Brute force approach. A naive approach would be to use nested loops to iterate through all possible starting indices and check if the concatenation of words matches the substring. We could start by checking every possible starting position, and for each of those, we check if the subsequent words in the words array are all found consecutively in the correct order. This approach has a time complexity that is exponential, O of n raised to the power of m, where n is the length of the text and m is the number of words. This becomes computationally very expensive very quickly, especially with longer texts and more words. Clearly not ideal for larger input sizes. So, we need a more efficient strategy. That's where our optimal solution comes in. Optimal solution. The optimal solution uses a sliding window approach along with a hash map to efficiently track word occurrences. We'll create a sliding window that iterates through the text, the size of which is equal to the total length of all words in the word list. As our window slides, we check if the words within that window match our words list. The hash map will help us count the frequency of each word within the window. If the frequency matches the frequency in the words list, we've found our solution. This clever approach dramatically improves efficiency. We'll utilize the sliding window to reduce the time complexity significantly. Code implementation. Let's see the code in Python. We'll start by initializing our hash map, which is going to be a dictionary in Python, to store word frequencies. Then, we will iterate through the text using our sliding window, updating the word frequencies as the window slides. We'll compare the window's word frequencies with the original words list's word frequencies. When they match, we add the starting index to our result list. We'll use helper functions to simplify the process and maintain readability. Remember those examples we looked at earlier? We'll use them to walk through how our code handles these cases, showing you how the window moves and the hash map changes at every iteration. Time and space complexity. Our optimal solution significantly improves upon the brute force approach. With the sliding window and hash map optimization, the time complexity is O of n times m, where n is the length of the text and m is the number of words. This is a massive improvement. The space complexity is O of m, primarily due to the storage of word counts in our hash map. So, we achieved a far more efficient solution compared to the brute force method. We've successfully traded the exponential time complexity for a much more manageable linear time complexity. This is a huge efficiency boost, allowing us to handle larger data sets much more gracefully. Engagement break. That was quite a bit of information, wasn't it? Before we wrap up, I want to thank you for sticking with me through this explanation. If you found this helpful, please give the video a thumbs up and subscribe to the channel for more coding tutorials. Let me know in the comments if you have any questions or suggestions for future videos. Your support helps me create more content like this, and I truly appreciate it. Thanks again for watching. Let's dive in. Conclusion. In conclusion, we successfully solved the LeetCode substring with concatenation of all words problem using an optimized sliding window approach with a hash map. This problem highlights the importance of choosing efficient algorithms for better performance. Understanding time and space complexities is crucial for optimizing your solutions. This problem is frequently encountered in technical